So welcome back. If I made this into a two-part video, we now have the other two modules. Let's start with the less complicated of the two, which is the, I say less complicated, which is the reverser, AWS, horn, and of course the screen that looks like a face. So let's crack into this. The reverser lever, designed to look like that from a Class 43, 3D printed on my Bamboo A1 Mini using their gold PLA, this is, and the key switch is a real simple one from Amazon, a real cheap key switch, just sunk into there and held in by a couple of grub screws. It is actually the key, which has been removed from its plastic and pushed into here. There you go, it is just a key switch, but it makes a lovely satisfying noise. Okay, I have to be fairly delicate because there's a fair amount going on in here. And there we go. So this is a 4-position rotary switch, Amazon special. I initially bought the wrong one. Obviously this is made in China. The switches go across from one side to the other, so each side is switched. These can sort of be rotated, which the wipers, you can't see, it was originally a 3-position one. I took it apart and it didn't go back together properly, but it was good enough. We have one side there, one side there. So on the other side you have the one wire going in and then the combined ground coming out, and that's for the 4 positions. We have an arcade switch here with a micro switch, really nice clicky switches. Used these for years, had this pack for a long time, and it has a 5-volt LED which runs straight from the power of the Arduino. Very nice, very simple. This is locked in so it can't rotate. I have a little jig to drill holes for that because it has a couple of little pins. Over here on this side, oh, can I rotate it without making a mess? We have the horn, which is a 2-position switch with the terminals on the bottom. Really try not to break anything here. And we have 2 ground, combined ground, and then the 2 switches that come from the Arduino. Really simple. Nothing complicated at all there. We have some grounds tied together with a wire nut here just because it was easier to fit in, as well as a couple more of those Wago style terminals. USB cable and port exactly the same. We have 3.5mm thonk jacks here. They're just all combined together on this Vero board. I can't remember if the wires are the same way around. Then we have the cable for the screen, which is a 4-pin cable there. It has a 4-pin header on the screen itself. You can just about see, and that comes to the Arduino. And finally the 2 buttons, which are just 2-pin buttons, again combined grounds, and then to the Arduino itself, and the light, which works the same way as all the others. This one isn't too bad for space inside. It gets much worse with that one. These screens are really nice to work with. You really don't have to have much code. It's fairly simple. That all goes together. That 4-position switch gives this a really nice motion. It's not quite the motion of a real one, but I think it works really well. And this is about as good as I could get it as far as the design, with a little bit of a curve to this. It needs to be this tall because the switch is inside, and it needs to have the wires. In fact, I may be able to show you. The wires need to come through here for this switch. So this is stood off from the back ever so slightly. I really don't want to break anything trying to show you this, but you can see in there are a couple of extra nuts where this would usually be pulled up against this plate, this back. There are some nuts in there which stand this off, so it gives the space for the wires to come through, because there's a shaft in there, square shaft. And that is that. And now it doesn't want to go back together, naturally. That's the more simple of the two. Now things get a little bit more complicated. You can see how many buttons are on here. It's going to be fairly tight inside. There really is only one way to take this off, and it's to tip the whole thing to the side. Let's see how well I do with that and not hit the camera with the screwdriver. Okay. Which way is it going to go this time? It's this side. You have to tip it. Yeah. You really aren't going to see much in there, unfortunately. I'll do what I can and maybe shed some additional light on the subject here. Inside, there is the Arduino. It's mounted onto one of these breakout boards. It's mounted onto a breakout board that gives you more sockets, more ports, or easier access to the ports, rather than having to connect straight to the pins. Good for thicker wires, and you don't have to solder them. Another one of these rotary switches. Like I say, I took this apart and put it back together wrong, but it does give me 2 positions, which is great. The rotary encoder has the 3 connectors there, and those it's treated as a potentiometer by the Arduino. We have these sort of cheapy industrial switches from Amazon, which have a normal open and a normal closed. Get rid of that. They have a normally open and a normally closed position, and they just work quite nicely as switches. They have a decent clicky feel to them. The emergency stop is the same. On this side, yeah, it's quite tight. You can just see a mass of buttons and wires. I have the guard switch here, exactly the same as the one in this one, illuminated by the 5 volts from the Arduino, and yet the rest of it is just switches. Now for this, to get more inputs, I've actually set this up so that it has a resistive divider here. You can see on here there are, can I get it into a decent position? You can see the resistors. What this does is couple to ground at different resistances when I'm pressing these buttons. The Arduino is capable of seeing that, and it's capable of producing an output based on that. This is exactly the same way that the potentiometer works. It's just a different resistance. That's all it is, and that is for all these buttons here. Because I didn't have enough inputs, these ones aren't connected to that, and neither are the 2 main ones. On the back we have another socket for 3.5mm, and the USB cable again that snakes around inside, and the light finally. That's it. Crikey, 9 minutes again. There we go. That is what's inside of these modules. This one has a loose piece of solder inside somewhere, I think. I haven't attached the bit of variable down there. It's okay floating inside. One of the issues I've had is this thing gets very, very close to the Arduino. I've had to shave off some of the connector because this was actually breaking the micro USB port socket from the board, and it's part of the reason why on the replacement boards I've purchased I've actually gone for the USB-C variety, which has more connectors to the board. It's a stronger connection, but it doesn't make a lot of difference now these are finished. They do just about go together. So that's what's inside these things. Nothing massively complicated. Any of you could do it. Just needs planning. Well, not too much planning because I didn't plan these very well, but just a bit of planning and a little bit of fabrication, and anybody can make one of these. Right, maybe next we might have a little demonstration of it working with the game, and eventually I might go into the code. It's pretty complicated and I don't like looking at it. I think I might lose a lot of people when I get to the code, or realise that my code's rubbish. One or the other. But for anybody who's interested, we can have a quick go through it and show you that. But thanks for watching this one, and I'll see you again soon.